Welcome, everyone. Thanks for joining me here on the Zoom box for a virtual tour of the Romberg-Tiburon campus and to learn a little bit more about the programs at the Estuary and Ocean Science Center. I'm Karina Nielsen. I'm Executive Director of the Center, and I'm also a Professor of Biology. And I'm really looking forward to showing you a little bit about what we do out here in Marin County on the Tiburon Peninsula on the edge of the beautiful San Francisco Bay. Come on, let's get started. One of the most important things that we do here at the Estuary and Ocean Science Center is we try to connect science, society, and the sea for a healthy planet. Nothing could be more important these days. I think the current circumstances remind us that this work is really important. And we're focused in particular on marine and coastal research, and we do it in a very interdisciplinary way. We also sponsor public science education programs, and our research is really focused on solution-oriented science for resilience and climate adaptation. We do this together with students at San Francisco State. The faculty at San Francisco State are the leaders of this interdisciplinary program. We also have two sort of partners, if you will, the San Francisco National Estuarine Research Reserve, which is a NOAA program that we host. So that's the National Oceanographic and Atmospheric Administration. And we also work very closely with the Smithsonian Environmental Research Center. Their main campus is based in Maryland, and they in Edgewater, on the edge of the Chesapeake Bay, and they have an outpost here on our campus, which is wonderful. Makes for a really lovely collaborative environment for students and faculty. So here's a picture from the air of the campus, in case you haven't been there before. And you may be wondering, how in the world is this connected to San Francisco State University, and how did we get it? And how do I not know about this place? Or maybe you've heard about it, but haven't quite been there before. So let me give you a little brief introduction to how we acquired this, this property. You may remember former President Paul Romberg. He was president from 1973 to 1983 of San Francisco State. And one of what he considered his most important achievements while he was president was to acquire this property on the edge of San Francisco Bay. And he got it for a total song. He got it for $1. And at the time, it was established as the Tiburon Center for Environmental Studies. When he passed away in a few years after he stepped down as president, sadly, it was renamed for him. The campus was renamed for him. And he had this vision that this was going to be a place where students could start working on the environmental problems of the day. He thought it was going to be just a really wonderful addition to the portfolio of experiences that San Francisco State students could have. Students, as you know, the campus is in an urban setting. In the 70s was a time when the Santa Barbara oil spill spawned basically the environmental movement, and 1970 was the first year that Earth Day was celebrated. And there was a lot going on at that time. Marine sanctuaries were being created. Everybody was really interested and concerned about the health of our environment. Much like people are today, only we have kind of bigger and more challenging problems. So one of the cool things is that even though this is a property that's not like super close to San Francisco State, it's really not that far. It's just right over the Golden Gate Bridge. This is a view of the Marin headlands from the Pacific Ocean. And if you come right in and you head through the Golden Gate and you head north, you will come across the Tiburon campus. And this is a map view, just so that you can get a sense of where we are. You can see the university and the yellow pin there, and then the little green pin is where the Estuary and Ocean Science Center is based, there on the Tiburon Peninsula. The Romberg-Tiburon campus is located on the currently occupied land of the Huimin, which were a band of Coast Miwok. And as you may know, San Francisco State University acknowledges the ancestral homelands of both the Ohlone and the Coast Miwok peoples, whose territories included what is now San Francisco County and Marin County, respectively. And of course, the indigenous peoples from many nations around California and elsewhere live and work in the Bay Area today, and they are among our students. The landscape was profoundly transformed when Europeans arrived, and one of the first steps was, sort of dividing up the land around Sausalito, and you can see a little arrow there on that old tide lot map that shows the Rancho Corte de Madera del Presidio. This was a Mexican land grant that was eventually became part of California. And the Rancho Corte de Madera del Presidio means it's the place where they went to cut the wood for the Presidio, or for the fort. So nice, interesting historical ties there. I'm going to take you on just a brief history tour of the campus, because when I take you in real time, in present day there, you're going to see artifacts of some of this history, and you're going to wonder what they're all about. So I'm going to give you just the briefest of introductions to the history of the campus itself. One of the first major activities on the campus was a business that was launched in large part as part of the birth of the U.S. Pacific cod fishery in the Bering Sea up near Alaska. And the cod was caught on these summer deployments, and they would salt it in the holds of the ship, and schooners would come back down the Pacific coast, and they would discharge their cargo at these cod packing plants. And one of the very first ones was Linden Hugh, and it was based in the cove that is now part of the Romberg-Tiburon campus. And they were operational from 1874 to 1904. And you can see all the fish drying there. You can see the extensive buildings that were there, and depictions of one of the schooners unloading there in a drawing from the San Francisco Call. There's an extensive article written about the activities here. It's a fun read. And then a photograph, obviously, of that vessel docked there. So that was sort of, one of the first major activities on the site. Later, in 1904, the Navy took over the site, and you can see remnants in the photo of the left of the shack that was part of the cod processing plant. But you can also see this big trestle and crane system being built. And this was the Navy's very first West Coast coaling station. And it was operated as such until 1931. You can see the big piles of coal over on the right. And actually that building that's sort of on the photo to the right, but it's tucked over in the right corner of that photo, is still on the campus today. So we have a number of buildings that are from that period. In 1933, another interesting moment in the history of the property, Roebling and Sons, which was an engineering company, had a lease on the northern part of the property, and I'm going to take you on a little tour of that northern part of the property, so you'll get a little peek at what it looks like today. But on the far right is a picture of a vessel that is pulled up on what we call the North Dock now, and you can see all the workers standing there, and you can see all these coils of steel cables. Well, they were coiling those and preparing those on our property on this campus, and they were barging them over and they became the suspension cables of the Golden Gate Bridge, and you can see it there being constructed. So we were connected to this really important, iconic bridge for the Bay Area. After that, from 1940 to 1958, the Navy ended up using the site for very important defense operations during World War II, is when it started, and it was known, and still known locally, as the Navy Net Depot. And the octopus was their mascot, and the idea was obviously to prevent submarines and torpedoes from entering into our ports and harbors, and that was the major business at the center on the campus then. And one of the things that they did in order to facilitate this work of assembling the net by hand with all the Navy folks was to create a big concrete slab, and you'll see that in the next photo. You saw it before. It's this big tarmac. And those nets were deployed across the Golden Gate and other ports and harbors. And then on the lower left there in that photograph, you can see some of the arcs in the water, little look like foam lines. And those are the nets. They were held down by weights. They had big metal floats at the top, and you can see the currents dragging on them. Very strong currents that go through the Golden Gate. And those nets were like 7 miles long, and they were active at that site and across the Golden Gate until through the Korean War in 1958. Anyway, today, this is what is left, a lot of remnants of that history. And most of the buildings, all of them date back to that period from 1904 basically to 1958. So that's the history that we're living with. And we are not, unaware of what the future holds with climate change and projected sea level rise. And one of the things that's a concern around the Bay Area, but also for our site, is that those areas that were filled and that were used for the Navy and for all those operations for building the Golden Gate Bridge, there is an enormous amount of modification that happened to that landscape. And those concrete areas, those seawalls, those areas of fill are incredibly vulnerable now to flooding and inundation from sea level rise during storms, etc. And you can see what we've plotted on the map on the right, which is an interesting to look at, is the historic shoreline in red from maps back in 1899. And then you can see another depiction in pink, and that's of what the shoreline was in 1943. So you can see the slab was built out, but maybe not all that fill was there initially. And then you can see what the projected water level will be with about 6 feet of sea level rise and a 100-year storm surge. So we're projecting out maybe about 100 years from now, is that those are the areas that would get inundated under a high storm event. And indeed, we already have overtopping of the seawall, certainly not that far back, but we do get inundation in the very edges of some of the lower lying areas of the seawall already. So that's something we're thinking hard about, but we're also, it's part of the kind of the research that we do, and it's an interesting problem for us to work on. Could be some demonstration projects here for how to deal with some of that and maybe use some more nature-based approaches in other areas around San Francisco Bay. I'm going to pause here because we're going to show a film clip. And I'm going to take you on a really quick virtual tour of the campus and then a little exploration of a bay beach on the north.
Welcome to your virtual tour. Here we are entering the main entrance, home of the Estuary and Ocean Science Center here on the Romberg-Tiburon campus. Lovely woodland as you come into the main campus. And you can see the architectural artifacts of the history of the site. Our finger pier out there with a weather station and water quality monitoring equipment, remnants of the larger pier that used to be there. Some of those weights there, those were used to deploy the submarine nets across San Francisco Bay. And on the left over here is our research area with lots of mesocosms, and you've got bay water flowing through the tanks to mimic the conditions in the bay. Lots of students and faculty do experiments there. Our solar parking structure on the right, and Delta Hall, the main research labs.
Now we've hopped over to the northern end of the campus, and you're looking out across San Francisco Bay over to the East Bay, and you've got the Richmond Bridge over there, just to give you a sense of place. And we're standing out on the edge of an area that was filled and seawalls were put in to create a dock area and a working area. That's sort of falling apart right now, but if you go just a little bit further along, you can find your way down to a more natural shoreline. And this is one of these really lovely little bay pocket beaches. And it's a great place to bring students to study the ecology of San Francisco Bay and of estuaries and beaches. Right here we're approaching a rocky bench that is covered with a variety of seaweeds, intertidal seaweeds. These are related to land plants, but they're quite different. The green seaweed there is probably the closest relative of terrestrial land plants. Got a couple of other species there. Now we can pull back and really get a sense of the ecological zonation that happens. And this is a result of the tides, exposing some areas of the rocks more often than others. And then we pulled over here to one of the boulders that was in the distance, and you can see up at the top there are these beautiful littoral zone lichens, orange and white and black, several species that are there. And as you may know, lichens are a symbiosis between a fungus and an alga. These are really special because they're marine lichens and they go underwater every day at every tide. That's pretty unusual. And as we run down the side of this boulder a little further, we're going to start bumping into some of the other marine life. You can see there's a pair of littorine snails there, all nestled into the little holes in the rock. A couple more nestled into that little crook there. Now we're getting into the green algal zone, Ulva enteromorpha. These are tubes of green algae. They're single-celled, thick tubes. And that little white area, it's been bleached out a bit in the heat stress of the summer low tides. And as we go down a little further, we're going to start bumping into our crustacean friends, the balanoid barnacles, or the acorn barnacle. Just below is the red seaweed that is the same species that is used to make the nori, or the wrap of your sushi. And then down below over here, we're going to see the red alga, Mastocarpus papillatus. And right next to it is the brown seaweed, Fucus disticus. It's also known as the rockweed. And it's a really important canopy former of the intertidal zone. You can see those swollen floats that it has there at the end that help keep it afloat when the water comes in. Well, I hope you enjoyed that little naturalist tour of one of our two bay beaches here, one on either end of the Romberg-Tiburon campus. As you notice, there's a lot of seawalls. There's also riprap. There's a lot of armoring of our coastline. And in fact, the only places where you have natural shoreline are on the two flanks, the two edges of the property. And they're really wonderful little beaches. Great places for learning about the ecology of San Francisco Bay. And one of the really unique things about our center, and one of the things that makes it special, is that it's a really terrific refuge from the hubbub of an urban university. And for a marine laboratory or field station, it's actually very accessible. Most of these kinds of settings that are owned by universities are at quite a distance from the main campus. We are actually very close. The distance feels far sometimes for students and faculty because just crossing the Golden Gate Bridge is a mental barrier in some ways, but the actual physical distance is not far at all. And what is cool about this is that students who might not be able to go and travel 4 hours for an overnight trip, or to go spend a week or a month in residence at one of these really extraordinary field campuses, they can come here for a day trip. They can come here for multiple day trips. They can work, they can have other things going on. This is a remarkable asset for San Francisco State students. It's also a remarkable place where students who might not normally choose careers in environmental sciences, in the marine sciences, particularly students of color, because they can't afford to go to these faraway places. They can come here. And we hope to really expand access to the station, to the Marine Lab, to the center, to a whole new generation of students. Anyway, that's our aspiration, and we're working hard to do that. One of the other nice things is that for students who attend and faculty who work at a very urban university, what a lovely refuge to have so close to the main campus. We're surrounded by an upland nature preserve, open space, park just around the bend, Paradise Beach Park, and extraordinary bay shoreline, as you just saw. And even though the distance feels far, it's not that far. You can take public transportation and get to downtown Tiburon, either buses that come into town or the ferry. And when you take the ferry and you land in downtown Tiburon, we're a little over 2.5 miles from downtown. And the bike ride is beautiful. Matter of fact, Paradise Drive, which is the single point of access to the campus, is a super popular, very scenic, and very enjoyable bicycle ride. People from San Francisco take the ferry on the weekends. You can hardly drive your car without bumping into a bike rider. Don't bump into them, but I'm just saying it's a thing, and it's just really, really pleasurable to ride your bike here. Anyway, I hope you get a chance to come and see us one day. Give you a sense of the wonderful group of students and faculty and staff we have out here. This is a photograph right before the start of the fall semester a couple of years back, welcoming our incoming cohort of graduate students in the Interdisciplinary Marine and Estuarine Sciences graduate program, right in front of Delta Hall, the main research laboratory, together with some of our faculty and staff. And this campus allows us, because it's right on the bay shore, to launch small boats from the property and get kids out on the water and doing hands-on marine science. We know that being involved with hands-on learning is a high-impact practice for all of our students to learn science. And the kinds of research that the faculty are doing together with students are at the center of some of the most important environmental issues of our day for coastal ecosystems and ocean ecosystems. The issue of plastics in the ocean acidification, and how it's playing out in the San Francisco estuary. Invasive species and the way they hitchhike around the globe and infect, if you will, estuaries that are and coastal ecosystems far afield from their hometown. What are the ways in which we might restore the health of San Francisco Bay? Could sea otters make a comeback? What are the ways that we can adapt to sea level rise that use more nature-friendly approaches, and that actually achieve two goals: a conservation benefit and protecting our shorelines from rising seas? So those are the kinds of research projects that we're doing. And our faculty and students, we do these with external funding from a lot of community agencies and scientific agencies, and we do them in partnership with the community. We work in Richardson Bay, at Sears Point, and a tidal marsh restoration project. We're doing ecological studies of bay beaches, the Living Shorelines project in San Rafael, and up at Point Pinole over in the East Bay. And these are really, really wonderful projects for students to get involved with. One of the other extensions of this campus is that we host a national program. It's called the National Estuarine Research Reserve. I mentioned it at the opening of the presentation. And the National Estuarine Research Reserve is a program that encompasses 29 special places on the estuaries around the nation, and we're one of them. And part of our responsibility is to steward two of the best and most pristine remaining marshes and intact uplands in San Francisco Bay, at Cheney Camp State Park and at Rush Ranch. And we work together with California State Parks, the Solano Land Trust, and the Bay Conservation and Development Commission to steward these properties. And these are places where students come and do research as well. They're a really wonderful resource. So that's like 3,700 acres of tidal marshes and wetlands. We also work on taking all that knowledge that we generate from the research that we do to work also on science-informed climate adaptation solutions and policy guidance for California. And I'm just showing you there a smattering of some of the reports that we've been involved in. Very important work. Recently, we started a new Master's in Science. It's called the Interdisciplinary Marine and Estuarine Sciences Program. And it is focused on solving these really complex problems at the nexus of global change, coastal ecosystem, and societal challenges. And we took what we already did well, and we applied to the National Science Foundation to get some money to really take our work to the next level with our graduate students. And we were fortunate enough to be funded by the National Science Foundation, a competitive research grant to the tune of almost $3 million to innovate with our graduate program. This interdisciplinary degree did not exist before we had the grant, and we just welcomed our fourth cohort of students into the program. And it's a model for how to do excellent training at the master's level. That's one of the hallmarks of the CSU, is that we focus on master's degrees at the graduate level. And most other research institutions and PhD granting institutions, the master's degree is often a consolation prize. We instead view it as the main dish, and our students do really well. And in fact, NSF gave us this award. At the time that they gave it to us, we were the first and only master's degree only program that had ever been awarded this grant. And to date, I think we're still only one of two. So we are really at the forefront here. I want to end the program sharing with you a videotape that our students made and about the program, and I hope you enjoy it. The Riptides program is a really wonderful master's degree program. It brings together students who are interested in solving problems at the nexus of global change, the pressures in coastal ecosystems from human impacts, development, those kinds of things, and trying to solve problems that affect people in their everyday lives. One of the great things about having this program here, right on the edge of San Francisco Bay, is that we have a variety of highly modified ecosystems and coastal areas, a lot of development, a lot of agriculture, interspersed with very natural areas. And we're confronting the problem of sea level rise. And so on a day-to-day basis in the news and planning in the communities, there's discussion of this nexus between the interest in conservation, impacts that sea level rise are going to have on people and coastal infrastructure, and how do we solve those problems?
I am broadly studying eelgrass invertebrate community ecology here in San Francisco Bay, and looking at how those communities have been affected by a low salinity event or a storm event here. In looking at how these communities have shifted in response to this storm event, it's going to better help predict what they're going to look like in the future, especially since we anecdotally saw a disappearance of some key native grazer species.
My research focus is at the intersect of 3 different disciplines: marine science, geographic information systems, and the social sciences, to help better understand about whale and turtle entanglements and fishing gear within small-scale fisheries in Peru. And these research objectives are to provide both the fishermen, local managers, the academic community with these risk maps that show areas of high risk for both of these marine species and the fishermen whose livelihoods can really be impacted if their gear is damaged from these entanglements and unwanted bycatch. The Riptides program have given me a lot of skills in different ways. One, in just being able to read scientific literature effectively and rapidly, and also being able to apply these skills and methods that we've learned about to my data and my research. Also, in communicating my research to a broad, different audiences, I learned a lot about how to interact with the locals by watching them and observing them, and then taking that skill on myself to do it.
During my time in the Riptides program, I've gotten to work with professionals from many disciplines. Together, we tackle multifaceted issues using both field and laboratory methods. I really feel that these experiences have rapidly developed not only my critical thinking skills, but my ability to communicate and work in a multidisciplinary setting.
Well, I hope you enjoyed that last little clip. We had a blast making it with the students. And it gives you a sense, I think, of the energy and the importance of the work that we're doing at the center and the value of having a campus like this as part of an urban university. That concludes the presentation for today. I look forward to having the opportunity to see you at the center in the very near future, where we can walk around in person, or you can come to one of our public programs. In the meantime, if you want to learn more about the work that we do, I hope you'll visit our website, eocenter.ssu.edu. And if you do visit there, you'll notice that we have some virtual seminars. If you're interested in topics related to the coastal environment, you might want to pop in on one of those. They're on 3:30 on Wednesdays. Anyway, for now, adieu, have a good day, and thank you for joining us.